This section covers fine-grained multi-threading. I will describe what it is as it pertains to the MIPS multi-threading architecture. First, we'll talk about POSIX threads so we can get an idea of what threading is. Then I'll go into fine-grained multi-threading for the MIPS MTASE. POSIX implements threads as a multi-threaded execution model that allows multiple threads to exist in the context of a single process, sharing the process's resources, but able to execute independently. Each thread is scheduled by the OS by time slicing or when another thread is waiting for an event, such as I/O. Fine-grained multi-threading as executed by the MIPS multi-threading architecture implements multi-threading as an execution model that allows multiple threads to exist within the context of one CPU. Threads share some CPU resources, but are able to execute independently. Each thread is scheduled by a policy manager. This is a way of controlling the priority of each thread. Each thread has its own general-purpose registers. This enables each stage of the multi-threaded pipeline to contain instructions from different threads, so that execution of those instructions affects only the registers of the thread the instruction is from. The CPU scheduling through the policy manager takes advantage of stalls in the CPU pipeline, such as when there is a cache miss. This slide illustrates how three threads can operate within the same common pipeline. The pipeline alternates instructions from different threads. Threads execute in this manner until there is a cache miss. When there is a cache miss in one thread, the remaining threads continue to execute. The MT implementation is made up of virtual processing elements, or VPEs, and thread contexts, or TCs. A VPE is an instantiation of a full MIPS ISA sufficient to run an OS. A VPE can be thought of as an exception domain, as exception state and priority apply globally within a VPE, and only one exception can be dispatched at a time on a VPE. Think of each virtual processing element as a bucket that contains threads. It represents the context of the processor. A VPE is a set of control registers and resources that are shared by all threads that are assigned to that VPE. A conventional MIPS core embodies a single VPE with one TC assigned to it. Each virtual processor looks and behaves like a single processor to the software. A thread context, or TC, is the hardware state necessary to support a thread of execution. This includes a set of general-purpose registers, a program counter, and some coprocessor state. A thread of execution is a single sequential instruction stream. Here is an illustration of how resources are distributed within an MT core. These are the resources that are common at the core level: the pipeline, the instruction fetch unit, the L1 caches, the load store unit, the multiply divide unit, the arithmetic logic unit, and the memory. There are also CP0 registers, which are shared by all VPEs. Each VPE has its own MMU, TLB, and exception and interrupt logic. All CP0 registers that are not common to the core are duplicated for each VPE. In addition to the standard MIPS CP0 registers, there are additional registers that are defined to be per VPE, common for all TCs within a VPE. There can be 2 virtual processors per core. Each thread has its own general purpose registers, internal program counter, and there are also several CP0 registers in each thread context. There can be up to 9 thread contexts in each core. Each thread context can be associated with a specific VPE. All the MT-specific CP0 registers will be discussed more in upcoming sections.